You're listening to Medex, the Medical Extrusion Podcast, presented by US Extruders. Extrude with confidence, custom extrusion equipment designed for you and your application.
Anant, thanks for joining the Medex Podcast.
Thank you very much, Steve, for having me on this Medex podcast. Looking forward to the discussions. It has been a long time waiting.
Yes, sir, it has. And I'm looking forward to this discussion because it's one of my favorite topics, obviously, medical extrusion, balloon extrusion, balloons, and of course, medical devices, the delivery of stents energy via balloons. So I'm looking forward to this conversation. And maybe where we can start, if you can kind of share your experience with our listeners and highlight some of your technical knowledge in the area of medical extrusion, balloon tubing extrusion, and balloons.
Thank you. I have over 35 years of experience. I have over 35 issued patents. I've been named as the inventor, co-inventor.
Yeah.
There are many patents still pending. My passion is product development, especially the balloons and extrusions. So over the years, I have honed my skill in this area. My educational background is in chemical engineering. Focus was on polymer science from India.
Mm-hmm.
And over the last 35 plus years, I have been working in this industry. I've honed my skill, especially here at Medeologix. We pride ourselves with high quality balloons. High quality balloons requires high quality tubing as well. So we pride ourselves in being able to produce high quality tubing to produce high quality balloons. The balloon forming process, I just wanted to briefly touch on.
Sure.
So when we extrude tubing looks something like this, single lumen. I'm using a nylon tubing as an example. So we take the tubing like this and form it into a parison. Some people call it a slug.
Yep.
Basically, we neck on the two sides that allows us to put the tubing inside the balloon mold of desired shape. Then we pressurize it, heat it, hold it, then allow the parison to soften. Then we stretch it and form it into the balloon shape. It fills the cavity of the mold, forming the balloon. Then once the balloon is formed, looks something like this. So you have some balloons in your package as well.
Yes.
So these balloons should be free of any type of defects, namely fish eyes, zipper lines, or foreign materials. Those defects could cause premature failure of the balloons.
Want me to share my screen and to go over some of those defects now?
That would be wonderful.
Okay, yeah, let's go through those.
Yes.
We'll start with the zipper line.
Yes. Zipper line comes from the extrusion itself. So these could be because of the die or the pin having a burr that causes the zipper line, which may or may not be visible when you look under microscope on the tubing itself, but it will show up when you form it into a balloon because now it is expanded very nicely, so it is visible. These cause the balloons to rupture prematurely during fatigue cycle. It may not show up when you do the straight burst. The fish eyes is the next one. So this is basically a void left behind by the evaporated moisture. So these can cause premature rupture of the balloon as well. Then some of the other defects are, that's another fish eye.
Yeah.
Then some gels also you can see. That's another fish eye. Here is foreign material. Basically, this is burnt plastic Sometimes these burnt plastics can come from not properly cleaned extruder, or also some pellets itself can have some foreign materials. These come through and end up in the tubing. Then this can cause premature failure of the balloons as well. We pride ourselves at Medeologix. We have the ability to screen these by the use of fine mesh candle filters. So that's why I wanted to show you the tubing that we extrude are free of foreign materials, gels, things like that nature. And also, we produce high quality tubing. During the extrusion, when we set up, we have certain parameters in addition to the ID, wall thickness, concentricity. We also look at the tensile properties of the balloon tubing.
Yes.
The tensile property is crucial for balloon forming. You can develop the recipe for pretty much any tubing. However, in the production environment, consistency is key, because you want to develop a recipe, lock that recipe, and set it to production. That in the production, you don't want to keep changing. For that, you need a very consistent tubing. So we start the extrusion with a certain tensile properties per the specification, and we constantly monitor during the extrusion to make sure that the tensile property of the tubing that we are collecting is still within the specification. You will see the graph that I sent you. This particular graph shows beginning, in the middle, and at the end of the extrusion. The tensile property is very close to what our set parameters are. This is within the specification of the customer. This allows us to produce balloons with a single consistent recipe on a consistent basis with a very high yield balloon. As you know, the balloon prices are going down. Everybody is highly cost conscious. For that, only way we can meet the customer specifications and also be able to be profitable is having high yield process. So high yield process is not just only in the balloon forming, also in the extrusion. So we pride ourselves with high quality tubing, and that allows us to produce high quality balloon at very high yield. So we can be able to produce balloons at the target price of the customer.
You know, it must be nice to be able to have the integrated capability extrusion and balloon forming within the same building, right? Because I hear all the time, there's some other great balloon forming companies out there. I'm sure you're aware of many of them, and a lot of them rely on multiple sources for tubing, vendor A, vendor B, vendor C, maybe who has the best price. You might buy that lot, but maybe you buy a couple, and you might make the tube to the same dimensions, but even if the elongation is the same, it's still a different extruder, different tooling, different everything. So I suspect that you have some lot to lot variation and maybe lower yields as well.
You touched a very important point. When you buy tubing from supplier A, supplier B, supplier C, they don't necessarily always be the same. I went through that when we were just MediBalloon by ourselves. We did not have the extrusion capability in-house. So I used to buy tubing from various suppliers, and I went through those issues. Then when we set up the Medeologix, we made the decision to have the extrusion capabilities in-house, which allows us to really control that. One additional thing I would like to point out, the raw material, the pellets that we buy, whether it is nylon or P-bags, There will be variation from lot to lot. One time, the material that you receive works very, very well, and that is not necessarily always true when you receive the next batch of material. Especially with P-bags, it's very true. The lower durameter P-bags from one lot to the another, it varies a lot. So we need to figure out what is the proper way to extrude it, the temperature, drawdown ratio, the puller speed, all of that. Then figure out what is the actual tensile properties that we need to meet in order to be able to have a consistent balloon forming recipe. So that is an experiment one has to run prior to finalizing the extrusion. And then only you can assure you have a consistent recipe for the balloon forming. So we have that capability in-house. And one time you supply a tubing, second, third, and fourth time, and going forward, they can be assured that they receive similar quality tubing from us all the time, because we monitor all these parameters and we test them during the process and also prior to releasing the lot of that tubing. We test and assure the quality. So that's where we differ ourselves from the rest of the extrusion houses. Just our pricing will be bit higher. A high quality product demands high price as well. But customers can be assured during their balloon forming process, they can see the benefit of a slightly higher price. Ultimately, when they look at the cost of their product, I think it will be still far cheaper than buying tubing from many other cheaper sources and trying to yield a balloon around 20-30% yield. Then you are throwing away a lot of material. More importantly, the labor went into producing those balloons. You have to take that into consideration. So I think even if the balloon tubing from Medeologix is slightly higher, the quality speaks for itself. I think they will see the benefit of that when they form balloon and have a reliable process.
Okay. You talked a little bit about the materials that you work with. Can you get into that a little further, and then maybe segue into the different types of balloons from those materials related to compliance levels?
Yes. So we produce balloons with various material, polyurethane mainly, various different types of material, isothane, palathane, carbothane. Again, in that various different hardness, anywhere from 75A, Shore A, to 55D palathane, we extrude and make balloons using those materials. These are mainly for compliant balloons. Then we also produce balloons using P-bags. These are semi-compliant balloons, 35D all the way to 74D P-bags. These balloons we produce in-house, extrude and produce balloons. We also produce nylon balloons. We extrude various different nylons, Grillamed, Asnamed, and Westamed Care, ML21 and 24 materials we use. We also produce PET balloons. PET is well known for its very thin wall, high burst pressures. These are also considered non-compliant balloons. We produce all of these in-house.
The non-compliant PET balloons, it sounds like they're still around, right? I thought for a time maybe PET would kind of go away and be replaced with nylon, especially for bonding, I guess. But you're saying that PET is still a popular material for non-compliant applications, high pressure maybe?
They are using them in a very small number of cases. If I were to look at the percentage, 70 to 74 DP backs and the nylons are the major ones for semi-compliant and non-compliant balloons. They cover 80% of the market. I say about 15% is about compliant balloons. Then less than 5% is PET.
Okay.
Yeah. So compliant balloons are dominated by the polyurethane materials these days. Isothane is the other polyurethane material making waves. What I like about isothane is lot to lot variation is not there, whereas polyurethane lot to lot variation is significant. We really have to figure out how to extrude them.
The compliant TPU balloons from isothane, for instance, are those used more in the larger balloons, like the GI space? You have larger diameters.
Yes, yes, they are typically used in GI applications and also for the AAA applications.
Oh, yeah, there you go.
Yeah. So here is a polyurethane. This is a ATA balloon. It's very soft, and this can grow to very large diameters. This is just an example.
Yeah.
We produce balloons anywhere from few millimeters in diameter all the way to 45 millimeters in diameter.
Wow. That's that a few millimeters. That maybe that neurovascular or ENT or something like that, right? Maybe.
Yes, neurovascular balloons. We make balloons from applications head to toe. Okay.
Yeah.
So neurovascular balloons are small diameter and very short balloons. Then you will see some of the balloons below the knee. Those are very long, 320 millimeter long balloons. So yeah, we can produce. Longest one I produced is 320 millimeters.
Wow.
So this is about 200 millimeter long balloon.
Yeah.
This is only 3 millimeter balloon. So these are used typically for below the knee applications. We also have the ability to produce intra-aortic balloons. So those are large diameter, long balloons. These vary anywhere from 20 millimeter to 28 millimeter in diameter. The length is anywhere from 120 millimeter to sometimes 220 millimeters.
Wow.
So we produce those balloons as well. These have to survive many cycles. These could be in the body in the patient for up to 29 days. So have to survive many millions of cycles. So we have the experience producing such balloons as well.
I want to go back. That's quite a range.
Yes.
Not only in the diameters, but that peripheral balloon below the knee. That's amazing. Back to kind of high pressure balloons. I was having a conversation with a gentleman recently, Dr. Thubakor aortic valve. He has his own valve, and he was talking about pressures and something that really stuck with me. He was talking about the delivery of like a TAVR valve, maybe 8 to 9 atmosphere. And he said, in your car tire, that's like 2 atmospheres. Like, wow.
Yeah.
Delivering that type of pressure on soft tissue. I know you have a lot of experience in high pressure balloons from your past as well. If you can kind of touch on that a little bit.
No problem. People have misconception when the balloon gets inflated to, say, 30 atmospheric pressure. That 30 atmospheric pressure is not necessarily exerted on the outside body structure. That pressure is needed to expand the balloon and also expand the outside structure. Physician typically gauges the size of the balloon required to dilate or expand the structure, the lesion. So these types of pressures are required to assure full dilatation of the processes they are deploying. In this case, say it could be a aortic valve or it could be a stent. When you expand, you want that balloon to expand like a cylinder, not like a dumbbell. Often what happens is when they inflate the balloon, the two ends expand like a dumbbell, dog bone, by leaving the middle structure not expanding if the balloon is not a high pressure balloon. So in order for these to expand like a cylinder, high pressure balloons are required. You need to apply high pressure. I had the opportunity to develop fiber reinforced balloon at Loma Vista Medical. Worked with several intelligent people, Alex Tilson, Mark Scheff. So I'm also one of the named co-inventors on the balloon. For that reason, I won't be able to get into the details of that balloon and the application. Generally speaking, high pressure balloons allow you to expand processes to its rate named diameter without over expanding. So that's the advantage of it. Without going over. So that's the advantage.
Okay. One other question, then we'll move on. I wanted to talk about some of your secondary operations, but one other challenge with balloons, if you can address this or not, is this watermelon seeding concept. Has there been anything done for balloon designs to overcome some of that challenge?
Yes. So those are textured balloons. So we have the ability to produce such balloons. Typically, the balloons, when some of the balloons can slip in the lesion without dilating the lesion. So people tend to put surface texturing to eliminate that. So that is something we have done as well at Medeologix. We have the experience with that. Some balloons, drug-coated balloons. We at Medeologix don't have our own drug, but we have the ability to produce balloons for drug coating applications as well.
Is that surface treatment for anchoring, we'll say, to avoid that slipping? Is that also advantageous for drug delivery?
Yes. The dosage can be increased by having a texture. So let's take 7 by 40 millimeter as the cylinder section. You can increase that surface area significantly by texturing the balloon. So what it means is you can put a lot more drug on the balloon in that same 7 by 40 section. So you can inherently now increase the dosage of the drug delivery. So that's the advantage of texturing the balloon. Yeah.
Okay. Excellent. Anant, I could ask you probably 100 more questions and we go on and on, but we'll move on.
No problem.
We might have to do another episode. But let's get into some of the secondary processes that you're involved with. I know that you're beyond extrusion, balloon forming. There's some other value-added capabilities that you have if you want to go over some of them.
Yes. Balloon catheter, as you already know, is not just the balloon. Balloon is the business end. But to get that the business end to the target site, you need a shaft and a hub, all of that. So we have Medeologix is a one-stop shop. What it means is we have the process in-house, vertically integrated all the processes, balloon welding onto the catheter shaft either by split die bonding or laser welding. We have both of those capabilities in-house. The catheter tip needs to be formed. We need to create a traumatic tip. We have that capability in-house as well. The strain relief attachment and the hub bonding or insert molding capabilities we have in-house. As you know, a lot of these balloon catheters require pleating and wrapping. We do that in-house as well. A lot of the balloons require coating, hydrophilic coating.
Yeah.
In the west coast of the California, United States, we are the first ones to offer a licensed coating, BioCoat. This is a hydrophilic coating. It's a very slippery coating, has a FDA master file. We offer that coating. We can coat the catheter. This allows you to track the catheter to target site with the minimum effort. Also keeps the catheter free of any type of clot formation. So I cannot get into the details of customers' products. However, generally, I can tell you hydrophilic coatings are highly advantageous when it comes to catheter performance and tracking. We are the first ones to offer a BioCoat as the hydrophilic coating. We have the in-house capability to coat those catheters and deliver it to the customers.
Oh, wow.
Yes.
Okay. I was going to ask, and you did. I didn't have to. I was going to ask about coating. Sounds like the full tip to hub, the balloon marker bands.
Yes,
too?
we can attach the marker bands by swaging process. So that is very well-known process. Yes, we have that capability in-house. Yes.
Okay. End to end, tip to
yes,
hub.
one-stop shop. That's what we are.
Yes. Yeah.
I wanted to introduce Medeologix to your audience. We are one-stop shop. We have 3 facilities here in Union City, then San Jose and Taipei, Taiwan mass production facility. We are ISO 13485 certified facilities, all 3 places. FDA registered facilities. We are working under one quality systems, one quality system management. If we assign a part number here in Union City that is applicable in all our facilities, documents that we create in one facility is applicable in all 3 facilities. In Union City, we typically produce only components, balloons, extrusions, and heat shrink tubing. When I say heat shrink tubing, it's PET heat shrink tubing. In San Jose, we produce assemblies, and also we have customer order fulfillment center as well. In Taipei, we have all of these, and in a large scale, we have duplicated in Taipei, Taiwan. It is strategically located. We don't transfer everything, we duplicate. What it means is, if customer chooses to produce in United States, we have the ability to produce them in United States. If there is any type of disruption to supply chain, we can produce them in-house in United States. So customer don't have to go through any type of supply chain disruptions. We also have a Taipei facility. It is very large facility, state-of-the-art facility, allows us to produce in a large scale at a reasonable cost. So customer coming to Medeologix don't have to worry about, where am I going to go for a mass production? We have that taken care of. So this allows for seamless introduction into the market from the concept to commercialization and volume production. So Medeologix is a one-stop shop for that reason.
Yeah, you mentioned, most OEMs, they want to have dual source, maybe triple source to mitigate risk. Or if they can find a company that has multiple sites to mitigate risk, that sounds like that's how you're handling that.
Yes.
So good job.
Thank you. And one additional thing I would like to mention, we also have the braiding capability and lamination, both in US facilities as well as in our Taipei, Taiwan facilities. A lot of the catheter shafts, especially the electrophysiology catheters, they are braided, laminated constructions, you will see. So we have the ability to produce those. We also can produce coil reinforced catheter shafts. We have the ability to produce coils in-house. So monofilers as well as multifiler coils. So,
and that's where your PET heat shrink in-house can help with terminating the coil to a braid, for instance.
Yes, we can produce PET heat shrink tubes in a very thin wall as well as thick wall. Very small diameter, expanded diameter, going from 0.5 millimeter, which is about 20 thousandths of an inch, all the way to about 15 millimeters in expanded diameter. So we have that capability. Wall thickness ranging from 0.2 of a thou to 1.5 thou wall thickness. So that capability we have in-house. We first, of course, have to extrude the tubing. Then we subject that to expansion process. The heat shrink tube that we produce, shrink ratio ranges from 1.2 to 1. Highest we have produced is 4 to 1. Yes.
Wow. Okay. Very thin wall too. Low profile.
Yes.
Yeah. Oh yeah. There you go. Right?
Very, very thin wall.
Very thin. Yeah.
Tubing.
Yeah. No column strength.
Some of the heat shrink tubes, they are so thin, 0.2 of a thou wall, it collapses itself. In order to really see, we have to pressurize it with airflow and open it up. So keeping it open is a challenge. So operators have to keep a very low airflow, low pressure airflow, so that it kind of keeps it open so they can feed the wire or the device through. It's a challenge. We can expand customers.
Well, you need that thin wall, right, for lower profiles.
Yes, exactly right. One last thing I would like to talk about, extrusions. Here is a very thin wall, new soft material. We can extrude this. This is about 3 thou single wall, and the diameter is about 320 thousandths of an inch in diameter. As you know, this material, soft material, ADA, it's very difficult to extrude. In addition, extruding pinhole pre-tubing is a challenge. So we have figured that out. So we have the ability to produce pinhole-free, very thin wall, large diameter tubing in-house. We don't need to extrude these on a mandrel. We can directly extrude it to the customer specification.
Good thing. That'd be a big mandrel.
Well, a lot of people extrude those on silver-plated copper mandrel. And then they stretch the mandrel and remove it. Cost of that type of extrusion is very high. We have figured out how to extrude it without the mandrel. So the cost can be very reasonable.
You said that was that tube, that new soft 88 was like 3 thou with like 300 thou. That's tough.
I have extruded similar tubing. It's in 5 thou, 825 thousandths of an inch ID without a mandrel.
With that type of durometer, that low durometer. Wow.
Yes.
Wow. Not many people could do that or not. I can tell you that much.
Sometimes setup is the key. It takes a long time to set up. Sometimes customers want only about 50 pieces, and they wonder why we charge so much. People don't realize the challenge behind it. Extrusion is not just only a science, it's also art. There is a lot of art to that extrusion. People don't necessarily always appreciate the work goes into producing such complex tubing. So it's some people appreciate it when they see it. They realize they have the experience doing such work, then they appreciate it. But some people don't have that experience or the knowledge.
Yeah.
Why are they charging us so much? So we spend 5-6 hours just setting up, then collecting only 50 pieces.
Yeah. Well, I appreciate it. That's very interesting. That's a very interesting capability.
Well,
and that'll maybe that's podcast number 3.
Yes. Well, you produce the equipment that allows us to do such complex things. Okay.
Yeah.
So without the equipment, we cannot do it. Okay. So I thank you for beautiful extruders that you produce. So without sophisticated equipment, we cannot develop a sophisticated extrusion process.
Absolutely.
Yes.
We'll leave it there, right? Thank you so much. It's a great conversation.
Thank you so much for having me here. Really appreciate the time, and I would like to thank the audience for listening to me. And if there are any other questions or comments, please let me know. I'll be happy to discuss one-on-one with any of your audience.
All right. Excellent. Thank you so much.
Thank you. Great talking with you. I really appreciate you having me on this podcast.
Yeah, it was great, Anant. Great conversation. And like I said, we'll have to do it again. I think there's some more topics to cover related to balloons.
Yes, looking forward to it.
Thank you for listening to MEDEX, the Medical Extrusion Podcast, presented by US Extruders. Please subscribe to make sure you're getting the latest episodes. For video episodes, go to us-extruders.com/podcasts. All links are available in the show notes.